Hello and welcome to Grim 3D, where 3D printing saves the day. Today, we're going to recreate one of these little items, which is actually a vent plug for this water jug. Maybe you guys have seen these, you use them camping, whatnot, but these little plastic plugs that cover the vent hole quite frequently end up broken or lost. So today, 3D printing is going to save the day. So as I'm going to start designing this little vent plug right here, the program I'm using is Design Spark Mechanical. I like it because it seems to be pretty simple to learn, pretty easy to use. I don't know if it's the best out there or not, but I really like it. So I'm going to start up a new design. That shows me my plane there. I generally like to start looking down on top of the plane, so I'm looking down from the Z-axis down on the X and Y axis. I got a pair of calipers here that I'm going to do my measurements with. I've got my calipers set to millimeters, and I'm just going to start with this type of object. I'm going to start at the bottom, measure it as I go up, and design this one piece at a time. So I'm going to start by measuring the bottom circle. That circle is 12.5 millimeters, like 12.47, but 12.5 we can round. This isn't that technical, that critical. So I go up here and select my circle drawing tool, start at the center, and I want to put in 12.5. So there's my starting circle. This circle that's 12.5, this end on here, just this little tab that you would use to open it up or pull it out, is 2.6 millimeters high. So we can go with that. I'm going to then turn this a little bit. I'm going to pull the circle that I just drew up, and I'm going to go 2.6. All right, so this item right here is actually tapered for better grip, which we'll look at that later. Let's do the next circle. So on top of that bottom part circle, I'm going to measure the next one. It is 7.8 millimeters. So that's literally just the part that holds it out from the hole. It's not the stopper, it's just a little support. So back in my Design Spark, I'm going to go back to my circle tool. I'm going to tell it that it's already chosen the right, I was going to say that I was going to choose the plane, but it's already chosen the right plane. So I'm actually going to just draw out from there, and we're going to do our 7.5, measure twice. So we'll go with 7.8. So there we have it. Now I'm going to go ahead and I'm going to pull that up. My calipers tell me that that shoulder is approximately 7 millimeters tall. So I'm just going to grab that particular circle. I'm going to pull that up to 7 millimeters tall. And our piece is shaping up already. Now the next portion of this is actually, I don't know if you can see that on the camera, but this portion here that plugs into the actual hole in the water jug is actually tapered. So we're going to take a couple of measurements on that. At the base, its widest point, it is 6.6 millimeters, and at its narrowest point, it is 6.2 millimeters. So in my design spark, I'm going to once again going to go to my circle tool, start in the center. I'm going to draw out 6.6 millimeters, and then I need to know how tall to pull that up, how high to pull it. So this plug section here is approximately 7 millimeters tall again. So I am going to pull just this part of the circle up 7 millimeters. There's no taper on there yet, it's just the widest dimension all the way up. Now this portion right here that holds the vent plug in the hole, this part that holds the vent plug in the hole but is actually small enough for air to get around it, that we're going to do some measurements on right here, and it's actually rectangular in shape. So we're going to take two measurements. It is 4 millimeters wide and 2.8 millimeters thick. So 4 by 2.8. I'm going to go back up here and select my rectangle tool. I'm just going to measure out up to so I've got 4 millimeters and I have 2.8. Okay, notice that that's not centered. That's all right. We're going to go ahead and click on the pull button to turn it into a solid, and then we're going to move this. We're just going to move that back to center. Now we're going to go back to pull. Let's see how tall we need to make it. This is going to be 15 millimeters tall. So we are going to pull this rectangle up 15 millimeters. Now I'm going to go ahead and look at it from the side. You'll notice on my part here that this little arrowhead that holds it in the hole, okay, I'm actually not going to try to print that way, because this is going to be printing on the bed sitting like this. It's going to print straight up. So I'm actually going to invert this so that the angle is on the bottom so that the printer doesn't have to try to do this overhang. Okay, so that should be pretty easy. I'm going to select just a drawing tool for this. I need to select a new plane. I'm going to draw it on the side here. About how wide is this triangle? It's about 10 millimeters wide. So I'm going to select my line tool and make sure I'm on the right plane. I'm going to start in the existing body of my design. Just lean it a little bit, and then I'm going to come up on a 45-degree angle, which in this case is going to read 135. But I'm going to make sure that I come away from the center of my design 5 millimeters, so that as I come over here to make a 10 millimeter triangle, the 10 millimeter triangle is centered. Then I'm going to go ahead and I'm going to pull that, and I'm going to have it pull all the way to the other side. Okay, now I've got some gaps in here. That's pretty easy to solve. I'm going to actually just grab this and pull it up right into that triangle, and I'm going to grab that and pull it right up into that triangle. Design Spark Mechanical makes that pretty easy. So there we have a pretty good design going already, but you'll remember that on the original, this cylinder right here is tapered at the top, as well as that cylinder to make it easier to grab. So let's start with this top cylinder. We already have the outside dimension, or the largest dimension is already what it's set at, so we're going to actually grab this edge and tell Design Spark to pivot that edge. So I'm going to grab that. I'm just going to move that in 0.2 millimeters per side. So that doubles to 0.4. The taper on the bottom, we've selected the edge and we just need to taper it in. I suppose it doesn't really matter how much you taper it in. It really is just preference here. How about we go 0.7, and hopefully that'll give us a good edge to grab onto when we want to pull the pin out of our water jug. A couple of finishing items. You'll notice in my original right here that this top end of this is tapered a little bit or is rounded to help center this plug in the jug, in the hole in the jug. So we can do that pretty quick. We're using our pull tool once again. And then we're going to put this on pivot edge once again, and we'll just raise this edge up. We'll go up 1.5 millimeters. That'll get us a nice taper for helping it center on the jug. And the last thing, because this edge up here needs to go inside the jug easily, I'm planning to print this out of TPU, so which is flexible, but to make it a little bit easier to get in and out of the jug, I'm going to use my circle tool and select this plane to draw a circle on, and I'm just going to put in the top, but basically a circle that's just going to create an air gap. So as I pull that, grab this bottom piece and pull it through, it's going to create, the top piece we don't really need, let's just delete that. It's going to create a small air gap at the top so that when you go to put it in the jug, you can just squeeze these edges into the hole, and in that way hopefully it will stay in and it will be easy to get in and out, and it won't give us any trouble in the future. We won't be losing these. Hopefully they'll stay in a little bit better than the original. So before we can go to the printer, we've got to go to the slicer. So the slicer that I'm using is an older version of Cura that I got with my printer. It's not the most advanced, it's not the fanciest, but it does a pretty good job. It does what I want it to do without being overly complicated, and I kind of like using it. It's designed and calibrated for the printer, and it just all came as one package, and so that's what I've been using. I've saved the program. I've saved my water vent plug as an STL, and I'm bringing it in here, and so there it is. I want to make sure that I open my profile that I have saved for TPU. And I always make sure that I check my profile that I just loaded in to make sure it's what I want it to be. I think we could get away with printing this at a layer height of 0.15. I am going to do 100% fill density. Print speeds look good. I don't think I'm going to need any rafts or platform adhesion. I do want to make sure that I have 2 skirt lines on something like this, so that I have enough chance to prime the head, that it's ready to go when it finally makes it to the print. Under my advanced settings, there's my nozzle size, my initial layer thickness. I'm just going to put that at 1.15, so it'll be the same as everything else. TPU seems to like that okay. I don't have any dual extrusion. The speeds look pretty good. I always like to check my cooling fan. One thing that I've noticed with the Cobra cooler that I have on there with the radial fan is that fan speed of 100% is just too much. So for my minimum fan speed, I'm going to put in a 20, and for my max, I'm going to put in 50 for TPU. I have noticed that if my fan runs too fast, it cools parts too quickly and they end up warping or delaminating, which is no fun. So now that I have that all set up the way I want it to be set up, I'm not going to let it print one of these at a time, because as it rolls, especially in these smaller parts, as it rolls around faster and faster and faster, it's just too quick. It doesn't give the part time to cool enough that it prints solid and prints with a decent edge. So I'm actually going to right click this and multiply the object. I'm going to throw down, this case I'm going to go with 9 total on the build plate. That gives me enough for all of the jugs that I have, and some to loan to my friend, give to my friends that use the same kind of water jug. And then that's about it. I'm just going to have to go up here and I'm going to save my G code. And that will end up at my printer. Now, because I have my printer set up to run through Octoprint, which is a networked print server, if you didn't see my video introducing you to my makerspace, you'll want to check that out and see how the Octoprint is set up and where I have it and all that kind of stuff. But here's my Octoprint terminal. It's a web-based terminal. So I'm just going to grab my water jug vent and I'm going to put it in here. I'm going to upload it locally, so that goes to the memory in the Raspberry Pi, and go ahead and print that. Cue the time lapse. Well, here they are. Some of them I had to clean up a little bit. I just took my flush cutters and clipped some of the edges. Anywhere that there was a little bit of plastic left over, any kind of thing. You'll notice that I got the taper looking pretty good right in through here. And then when we try to fit one in the plastic jug, it goes in just fine. It stays in just fine. And when you want to plug the hole, it plugs the hole beautifully. So I'm calling this a win. TPU, it's flexible. Hopefully they won't break. TPU is pretty strong. Hopefully they'll be able to handle the heat of camping in the sun. Only time will tell. We'll have to figure that out as time goes on. Well, that's it for today's episode of Grim 3D. Hope you enjoyed it. Remember, keep the comments civil, keep printing. I'll see you next time.